In the kitchen, butter's behavior follows a predictable one-way path. When you apply heat, the solid fat breaks down and transitions into a golden liquid. This is a phase change. As the temperature climbs, water evaporates and milk solids separate, leaving behind the clarified liquid fat we know as ghee. Historically, dairy processing has always relied on this exact sequence. As seen in this traditional churning process, the goal is to stabilize the fat by extracting the solids from the liquid. Once that separation is complete, the process is considered irreversible. Under the standard laws of thermodynamics, you cannot simply rub liquid ghee and have it revert to solid butter. This photograph shows the Ganga temple in the Shivagange hills. It is the site of a reported phenomenon that challenges standard expectations of dairy chemistry. The local tradition points to the Samudra Manvan, the churning of the cosmic ocean. When the bull Nandi fell ill after consuming a lethal poison, his recovery was attributed to a specific medicinal intervention. According to the text, Lord Shiva manifested here as a Swayambhu Shivalinga, a naturally occurring stone, to produce a cooling, miraculous butter that saved Nandi's life. Every day, priests recreate this event. Applying liquid ghee to the stone's surface, manual rubbing appears to solidify the yellow oil back into white butter. This leaves us with two possibilities. Either we are witnessing a persistent ancient myth, or an undocumented physical anomaly is occurring in real time. Achieving a stable emulsion in a lab is a precise science. As this image of food analysis suggests, turning liquid fat back into a solid requires very specific environmental controls. Normally, you would need ice-cold temperatures, the addition of water, and sustained high-speed churning to force the molecules to bind back together. Here is the friction paradox. Rubbing a substance against a stone generates heat. This energy should cause liquid ghee to melt further, not solidify. Because heat is a solvent for fats, manual rubbing should cause the ghee to collapse into a thinner liquid. To test this, researchers brought in pure ghee purchased from external vendors, like the shop shown here. This was to ensure that no specific temple additives were responsible for the reaction. Even with this control sample, the result was the same. Using only bare hands and a small amount of water on the temple stone, the liquid ghee emulsified into thick butter in less than 2 minutes. The observation is startling. A process that usually requires industrial cooling and mechanical force is being achieved here through manual friction and body heat. To see if this was a property of the environment or the specific stone, investigators repeated the procedure on a different Shivalinga located just outside the main shrine. On the second stone, the ghee behaved exactly as expected. The friction produced heat, and the yellow oil simply thinned out and ran off the stone surface without solidifying. The butter produced on the primary stone exhibits a second unusual characteristic, its rate of biological decay. Standard homemade butter is highly perishable. As this time-lapse shows, it quickly succumbs to mold and becomes rancid when left at room temperature for days. In contrast, the butter from the Shivagange stone reportedly remains fresh and odorless after a week in the open air, suggesting the transformation alters more than just its physical state. We are left with a consistent observation. The 1,600-year-old tradition of a healing butter is mirrored by a daily physical event that contradicts standard thermodynamic predictions. From a material science perspective, one hypothesis is that this specific stone possesses an endothermic property, an ability to rapidly absorb heat. If the mineral composition of the stone absorbs heat energy from the liquid faster than the friction can generate it, it could theoretically force the fat to emulsify instantly, as shown in this model. Whether the cause is a specific geological rarity or something else entirely, the Shivagange anomaly shows that localized material interactions can still produce results that our current models don't fully explain.